Give the maximum capacity of each of the orbits. So when it comes to K, we know n equal to 1. The formula is 2n square. So 2, 1 square, maximum capacity 2. Next is the L, second orbit, n equal to 2. Formula 2n square, 2, 2 square, and that is 8. M, n equal to 3. Formula 2n square, 2, 3 square, 18. Then we have n. Here n equal to 4. 2n square, 2, 4 square, and that is 16 into 2, 32. 32 electrons. Define the octet and duplate state. Now, octet is when the outermost shell has 8 electrons, it is said to possess the octet state. Now, it's an atom. The atom is said to have possessed the octet state. And for the duplate state is when the outermost orbit is a K shell with 2 electrons. The atom is said to be in a duplate state. Give the rules for the distribution of electrons in an atom. This is from your page 50 of your textbook. The first rule is the maximum number of electrons present in a shell is given by the formula 2n square. Hence, we have already seen earlier that the K shell can take 2, the L can take 8, the M can take 16, and the N can take 32. And that's exactly what is written here. They've used the formula 2n squares. So the shells can take the number of electrons given by 2n square, where n is a number of the shell. The next is the maximum number of electrons that can be accommodated in the outermost shell is 8. So 8 electrons can be accommodated in the outer shell. And the next point, electrons are not accommodated in a given shell unless the inner shells are filled. That is, the shells are filled in a stepwise manner. So first the K will be filled. Only after the K has got 2, then we'll go to the L, which will take 8. After the L is filled, then we'll go to M, which will take only 8, not 16. Then we go to N, which will take 8. So first the inner shells are filled before the outer shells get filled. Define valency. So valency is a number of electrons an atom would gain, lose, or share to complete the outermost orbit. And valence electrons are number of electrons in the outermost orbit of an atom are said to be the valence electrons. Find the valency of oxygen. So to know the valency of oxygen, first we will write its atomic number. Atomic number of oxygen is 8. Then you have to write its configuration. That's the distribution of electrons, 2 and 6. So we see its valence electrons are 6, outermost electrons are 6. Now to gain stability, it has to gain 2 more electrons, because 6 plus 2 is 8. So it has to gain 2 electrons. So it will gain 2 electrons. Hence valency is 2. Of course, it becomes an anion. It's an anion, so it's got negative. Next is valency of sodium. We always have to know the atomic number. So here atomic number of sodium is 11. So your configuration means distribution of electrons 2, 8, 1. What is important is valence electrons. Now valence electrons is 1. Outermost electrons 1. So sodium will lose the 1 electron to get stability. To gain stability, it will lose 1 electron, and thus it then becomes 2,8. This is sodium ion. So valency is 1 of sodium is 1. Now for magnesium. Now magnesium atomic number is 12. So the configuration, electronic configuration is the distribution of atoms of electrons, so it would be 2, 8, 2. So we see valence electrons. Here are 2 valence electrons. So to get stability, the magnesium atom will lose 2 electrons. And hence, if it loses 2 electrons, the valency will be equal to 2. Define atomic number. Atomic number is the number of protons in an atom. Then we go to mass number. Mass number are the sum total of the protons plus neutrons in an atom. And then we have the nucleons. Nucleons are the protons and neutrons which are present in the nucleus of an atom are called the nucleons. So just to go over it again, we have atomic number is equal to number of protons, mass number equal to protons plus neutrons, and nucleons are the particles present in the nucleus, which are protons and the neutrons. They are called the nucleons. Give the difference between protons, protons and neutrons. So first we talk about the charge. Electrons are negatively charged, protons are positively charged, and these are neutral. Then about the mass. Electrons have negligible mass. These have considerable 1 AMU, they call the mass, considerable mass. Neutron also has got considerable mass. Then for the location, electrons are outside the nucleus. They are present outside the nucleus in the orbits. They revolve in the orbits around the nucleus. The protons are present in the nucleus. Neutrons also are present in the nucleus. What are isotopes? So isotopes are atoms of the same element having same atomic number but different mass numbers. Let's take the example of chlorine. Isotopes of chlorine. You have 2 isotopes and they have the same atomic number, so 17 and 17, but the mass numbers are different. One is 35 and other one is 37. Now for the isotopes of hydrogen. Hydrogen has got 3 isotopes, hydrogen, and all of them will have the same atomic number, 1, 1, 1, but their mass numbers are different. One is 1, 2 and 3. And let's write down the names. The one with 1, 1, this is called deuterium, and oh no, this is not deuterium, this is wrong, this is protium. Then the next one is, this is deuterium, and the last is tritium. Then we have the isotopes of carbon. It also has got 2 isotopes. Atomic number same, 6, 6, and mass would be 12 and 14. These are the isotopes of carbon. What are isobars? So isobars are atoms of different elements having different atomic numbers but same mass number. And examples would be calcium and argon. Calcium, Ar, argon is Ar. They have same mass, so both have mass of 40 and 40, but their atomic numbers are different. Here we have, this is 20 and argon will be 18. Now just to bring to your notice, their properties will be different. Chemical properties will be different because in calcium it is 20, so distribution of electrons 8, 8, 2, right? And argon it's 18, so it will be 2, 8, 8. So different chemical properties. Isotopes have different chemical properties. Isotopes have similar chemical properties. So point 1, I'm just writing it in points. You will say first isotopes have same atomic number, and because they have same atomic number, they have a similar electronic configuration. And similar electronic, in fact same electronic configuration, so they have valence electrons are same, so they have similar chemical properties. And the reason all because they have the same atomic number. Now isobars do not have similar chemical properties. Now remember, isobars have different atomic numbers. And because they have different atomic numbers, the electronic configuration is also different. Distribution of atoms is also different. And since the electrons are distributed differently, they have different chemical properties. So remember, atomic number is very important. They have different atomic number, different electronic configuration, hence different chemical properties. The mass of an atom is concentrated in the nucleus, and that's because electrons have negligible mass, and these are outside the nucleus. It is the protons and the neutrons that have mass or are heavy particles, and these particles are present inside the nucleus. So all the mass of the atom is concentrated in the nucleus because the heavy particles are present. Here's the nucleus. You have the protons and neutrons which are very heavy, the light electrons are present outside. So all the mass is concentrated in the center. Give the application of isotopes. This is from page 53 of your textbook. So the isotope of uranium is used in nuclear reactors. Then the isotope of cobalt, here cobalt, is used in treatment of cancer. And the isotope of iodine is used in the treatment of goiter. Which of the following are stable? So here we have just aluminium, which is an atom. And in the next case, we have aluminium plus 3, which is an ion. So we know aluminium has atomic number 13. So its configuration will be 283. Now look at the outermost electrons. There are 3 outermost electrons, so not stable. It has to have 8 outermost electrons. This is not stable. So in order to gain stability, what does aluminium do? It loses its 3 electrons and now becomes 2,8. Now this is the ion of aluminium. Since it loses 3 electrons, it gains a charge of plus 3. Now look at the outermost electrons, 8. So it is stable. So here the ion has octet state, hence stable. The atom is unstable. So aluminium plus 3 is stable, aluminium is not stable. How many valence electrons do the following have? Let's take up A. Remember sodium positive, which is an ion, and this is sodium, which is an atom. Let's start with the atom. We know atomic number is 11. So you have to remember the atomic number. So configuration 281. While when it comes to the sodium ion, atomic number is also 11, but it loses 1 electron. This sodium, since it is not stable, it loses 1 electron and now becomes 2,8. This 1 electron is lost. So here this is the ion. So here the valence electrons, the outermost electrons, in this case equal to 8. Here valence electrons is 1. Now we go for oxygen, B. For oxygen, we have oxygen atom, configuration 2,6, and we have oxygen ion, configuration 2, there are 6, so it takes 2 more, 8. So here valence electrons is 8, here valence electrons 6. The sodium atom will gain 2 electrons and become the ion, hence the configuration is 2,8. An element has 6 protons and 6 neutrons, 2 and 6 electrons. So we'll write down protons 6, neutrons 6, and electrons is 6. So we need to find first atomic number. So atomic number equal to number of protons, and number of protons we see are 6. So 6 atomic number. Now when it comes to mass, mass number equal to protons plus neutrons. So protons 6, neutrons 6. So it will be 6 plus 6, mass number 12. X, and we have X here 23 and 11. What does 23 represent? Remember, 23 is the mass number, and the mass number is always protons plus the neutrons. And then we have 11 is the atomic number. Atomic number is always equal number of protons. So in this question we have got to find how many protons are there. So protons will be equal to atomic number, which is 11. If protons are 11, electrons also have to be 11. So because protons are equal to electrons. Now to find the neutrons, we know mass equal to protons plus neutrons, and in this case mass is 23, protons 11, neutrons we do not know, so neutrons equal to 23 minus 11, and that is 12. So it has got 12 neutrons. How many electrons at the maximum capacity can be present in the first shell? The first shell is a K shell, n equal to 1. The formula is given by maximum electrons is given by the formula 2n square, 2 1 square, which is 2 into 1, maximum electrons 2. Name any 2 noble gases. So for noble gases we have helium. We'll just write its atomic number is 2, so configuration 2. Then there is neon, and neon atomic number is 10, configuration 28. And then we have argon, atomic number 18, configuration 288. Now what is so special in the configuration? See the outermost orbit 2, this is stable, outermost electron 8 here also, so stable, outermost electrons 8 stable. So what is special about their configuration is, in all the noble gases the outermost orbit is stable. And because the outermost orbit is stable, they are unreactive. They do not react. They do not lose, gain or share electrons, and hence they are unreactive. Identify the element and write its electronic configuration. We have X 27 13. Now this is important. Atomic number is 13, and aluminium has atomic number 13, so this is aluminium. So it is atomic number 13. So electrons, protons equal to electrons, so electrons also will be 13, and configuration will be 283. Now if you want to know even valence electrons is 3, so valency here it will give out this 3, so valency will be 3. Here I made a mistake. See, in this you've got to write your atomic number down, mass up, number down. This two, the 40 will go on the top, mass is down, atomic number is, yeah. So I'll repeat again, when you're writing an element X, the mass number has to be written on the top and the atomic number has to be written down.